Okay, so from this lecture on, we will start our official lecture. And as you notice here, we will actually now start it from the first chapter. We will start it from the fourth chapter. Okay, and the reason why is this textbook is actually a intermediate textbook for some student in some school. Okay, so the first three chapters are gonna cover really basic issue that you should have already learned somewhere else, like how to calculate GDP and that kind of things. And also, I think those stuff are less important in our class. Okay, so I will skip them and directly go to chapter 4. And chapter 4 is about consumer and firm behavior. The subtitle is the work, leisure, decision, and profit maximization. Okay, and you might find this topic or the title familiar, not from the macro class, but from the micro class. If you took some kind of micro class before, and it's talking about labor supply, or it talks about individuals, utility maximization, and the goods are leisure and the leisure and the consumption, then it's actually the same model. Why we're talking about this model in a macro class? Because this textbook or the course I'm actually teaching is more toward a neoclassical approach. Okay, if you took a macro class before, my guess is you took something, generally speaking, Keynesian macroeconomic. That means you study something called ISLM model. Okay, and to be honest with you guys, I did study ISLM when I was a undergrad, but I studied it in a international finance class in my last year of my undergrad, and I got a really good grade on final and also the final grade, but right after the final I forgot almost everything. Okay, so basically you can consider I know nothing about ISLM. Okay, so that's the first reason why I teach this, not ISLM sort of model. The second reason why is, like I said, this course is about methodology. It's about mathematical tool that is really useful or commonly used in macroeconomics nowadays. And nowadays, actually, very, very few economists are using the ISLM model. There are two popular class or school right now. One is called neoclassical, that's what I'm teaching right now, and the other is the neo-Keynesian. And what is neo-Keynesian? Neo-Keynesian, although its name has Keynesian in it, is actually close to neoclassical, closer to neoclassical. Okay, in a way that it is all micro-based macroeconomic model. What is micro-based economic model? It means that we were like building a I don't know if you play the game Minecraft. Okay, so you're building a world. You place some player in this playground, and you model each of their decision model. I'll tell you, or the way they behave, and then you see how they interact with each other. That's the basic idea. Okay, so in this chapter, we're gonna talk about two kind of actor. One is the firm, the other is the consumer. The consumer will do, which I call here the work, leisure, decision, and the firm will do what's called a profit maximization behavior. And we will not actually put them together. When we put them together, that's the macro model. So in this chapter, it's almost like you are studying microeconomics. Okay? But notice that the assumption in this chapter will be slightly different from your micro textbook. The reason is, because it concerns different questions. So you slightly tune the assumption so that the assumption make more sense in this context, or I should say that you make assumptions so that you can focus on the question that you really concern in this topic. So the learning objects here, the first one is you will learn how to list the properties of the representative consumer's preference. Okay, so as you probably should recall, any preference, or AKA it's monotone, it can represent a utility function, right? And that utility function or its preference, it needs to have some kind of property. Okay, and we need to know why these properties are useful. And also, you need to know how to construct the budget constraint for a consumer. And you will then show how you can, how this consumer can optimize his utility given his budget constraint. Okay, and that will also determine the labor supply, as you will see later. And lastly, it will determine the effects of change in the representative consumer's environment on his or her choices. That means we will do something, we change some variable and see how the decision is altered. Okay, it's like when like in microeconomics we talk about when price goes up, the consumer's consumption bundle will change, right? I'm talking about a X1, X2 goods and P1, P2 price, that kind of model. Okay, so when P1 or P2 goes up, consumption bundle will change. Okay, this is kind of the same logic we're doing here. For the firm part, we will list the properties of the production function and also why these properties are useful. And then we will show for a representative firm how they will maximize their profit. Okay, and this will then determine the labor demand and output. Okay, and so you can see here we got a labor demand here. In the previous page we will get a labor supply. So we will actually have a market that's a labor market. Where labor demand supply there, we will have an equilibrium there. But that's actually not in this chapter. We'll do that in the next chapter. And then we will again also show that when the environment or some variables change, what's the different behavior that this firm will do. Okay. Like I said, this chapter is still very, very micro, not really macro. Okay, so if you previously have difficulty in study macroeconomics, this is a really good chance for you. You can start with something that you are more familiar with, which is micro, and then we will gradually approach the macro question. Okay. Any questions so far? Is there anyone who took a macro class in undergrad and it was your teacher was teaching neoclassical model? No? The most famous person who's teaching this is Mao Qingsheng from the econ department, if you heard of him. Yeah, I took his class when I was an undergrad. Yeah. Okay, so for the representative consumer's preference over consumption and leisure can be represented using a indifference curve. That is, we are basically talking about X1 good and X2 good. But here, X1 is usually X1 is leisure. Wait, X1 is leisure, X2 is consumption. But it didn't matter. It can do either way. So then we will have an indifference curve, right? That's what you should, at least you should learn that last semester. And then we will show how to do the consumer budget constraint. Then the consumer's optimization problem will be easy. That's a constraint maximization problem, right? As you probably know, some of you probably will do, okay, based on my experience, see this question, some people will directly go to Lagrange optimization. Then, try to figure out the answer. Generally speaking, that's the right direction, but you will find that Lagrange is not always useful, or not that useful as you think. And think about the intuition behind the constraint maximization is more important in this course. Not to mechanically use the Lagrange multiplier and solve the questions. Okay. Okay, so since it is an indifference curve, and we have two goods, so no matter I put leisure here and consumption here, or the other way around, the more leisure is better for you, right? You want to take more leisure time. And the more consumption is also better for you. You want to spend more money on something. Okay, so this direction is good. And there's a trade-off between leisure and consumption. So the slope of this indifference curve will be negative. Okay. And it will also be convex, meaning any 2 points, when we connect them, these points are preferred than these 2 points. This point on this segment is preferred, strongly preferred to these 2 points. That's called convex. Okay? And the reason why we make this assumption is to make sure that this person will have a mixed bundle of leisure and consumption. It will not have a corner solution where it only consumes consumption and there's no leisure, or there's full leisure, meaning he spent 24 hours and 7 days a week for leisure. Okay? We want to avoid that, basically. So the indifference curve should look like this. Okay, I'm right. So leisure is usually put here, and consumption is here. Okay, and this should be micro review for you, but point B and point D are on the same indifference curve. That means they are equally preferred to each other, or we say that's indifferent between B and D. And A is strongly preferred to B, and since B is equally indifferent between D, so A is also strongly preferred to D. And there is a thing called marginal rate of substitution on the indifference curve. Basically, what it means is, on any indifference curve, at any point on a indifference curve, we can find a slope tangent to that point on the slope on the curve, and that is basically what you think as this consumer think, the trade-off between consumption and leisure. So if the slope, for example, is 1 to 3. What it means is, suppose the leisure is measured in hour, then it means if I sacrifice 1 hour and say 1 hour a day and gain, say this is $100 as the rate. So sacrifice 1 hour of leisure time and get $300 more per day. You are indifferent between these two things. That's your trade-off. 1 hour for you worth about $300. And notice that this MRS is changing along the curve, right? It means that when you have less leisure, the trade-off will be higher. 1 hour, if you only have 2 hours per day for your sleep, then if I ask you to sacrifice 1 more hour of your sleep, then you probably would ask me to give you much, much more than $300, right? So that's another reason why this curve is convex, okay? And consumer has a very easy time constraint. Here, H is a constant. It's a fixed number. You can think of it as like it is 24 hours. If you're talking about 1 day as the time scale is 1 day. If it is talking about 7 days, I mean a week, then we can think of this H as 24 times 7, that many hours. Okay. It depends on your time scale. You can also think of it as minutes, then that's a lot of minutes. But in any case, as you probably should learn since your childhood, everybody has a fixed time, fixed amount of time per week or per day or per month. That fixed amount is a constant. That's why H is a constant. In this case, we will just spend on 2 things. One is NS. NS is the labor supply. Or put it in another way, it's just how many hours you work. Okay. Or how many days you work. Depends on your skill. And this L is leisure. How many hours you spend on gaming or streaming or Netflixing. Okay, that's the time you spend on leisure. Okay, this is a very simple time constraint. Okay? And the consumer has another constraint, is the budget constraint. C is the consumption. How much this person spend or eat. And what does this person has in terms of how much he or she can spend? First thing is this person work, right? In our model, this person work. This is, if you haven't forgot, this is the labor supply. How many hours you work. This W is wage. Wage times hours, that means your salary, right? The other thing is this pi is dividend. Dividend from where? From the firm. In this model, because we need to close the whole model, so we assume that because in this small world, we only have 2 players. One is the consumer. The other one is the firm. Okay, so this firm must be owned by some person, right? But there's only one other person, that's the consumer. So we assume that the consumer actually owns this firm. If this consumer owns this firm, then it will get dividends or profit from that firm. Right? So this is it's like I own the firm, so I get the money from there. So pi is that dividend. T is tax. We are assuming not a proportional tax, a lump sum tax. Lump sum tax means it's a fixed amount of tax. So here it's also a constant. Notice that this is the biggest difference between the traditional micro model and macro model. Macro model need to sort of close the whole model. have a general equilibrium idea. The micro model, if this is a labor supply model, I will simply assume here, I will simply assume pi equals t equals 0. It will become an easier model. And we can still get a lot of the idea there. So it's actually not that different. But in macro model, we need to close the model, so we will need to assume that it also received dividend and it has to pay the tax. You will see why this is useful later on. Okay, so we have this, right? Leisure plus labor supply equals H. And we have this. The labor supply is here. So I can simply put the L here and replace the labor supply with H minus L, right? That's in plain language, plain English, that's how many hours you have as a person minus how many hours you spend on leisure. And then what's left is how many hours you work. So then we can rearrange this and becomes C plus WL equals WH plus pi minus T. Here, why do we put it this way? Because remember, we are concerning a model where the two goods that the consumer is consumed is leisure and consumption, right? That's the XY good or X1, Y1, X2 good that they're consumed. So we put the C and L on the left-hand side. That's the variable we need to determine. And these are what? These are basically all fixed constant. WH is your total hours you have times the wage rate, times the wage, plus pi and T are also fixed constant here. And if you draw them on the leisure and the consumption graph, you will find that it is a straight line. Because remember, this is constant. This is the variable that we draw on the y and x axis. So the slope here is negative w, right? So you will find that the slope is a constant and it's actually negative w. And it will intersect the leisure axis equals this. Why that's the case? You simply put consumption to 0, and you'll find that the leisure will be this. It's not that complicated. Okay, so then you have one intersection on one axis and the slope. Then you can draw this budget constraint. That's the budget constraint. Okay, but to do the budget constraint, we actually need to concern about one issue. That is, whether the tax is greater than pi or the tax is less than pi. What I'm drawing here is what is what? Which one is t greater than pi? Which one is t less than pi? Not that hard. Here is pi minus t and it's positive, right? So it must be pi greater than t here. So that's this case. When t is greater than pi, then it's very easy. Okay, you have a simple straight line. But when pi is greater than t, we will actually have a kink budget constraint. The reason is very clear. We should have a line like this. And so it intersect no. Oh, I cannot draw them, but it intersects somewhere outside the box, over there, right? But the most leisure one can consume is H, right? This person cannot consume more leisure than H. Okay, so to make sure that this is, the most you can consume on leisure is H, and when t is less than pi, you will naturally have this graph. You will have a kink case. This is also what the micro model and macro model are different, because we assume the dividend and the tax is available here. And because this kink case is more strange, so we're basically all concerning about this case. So a simple consumer optimization looks like this. We will push the indifference curve toward the higher utility direction, more preferred direction, until it cannot be pushed furthermore, so that it intersects. If it is a well-behaved indifference curve, that will look like this. It will intersect a point here. If the indifference curve look like this, okay, you still push the indifference curve out, but you push it so that it cannot be pushed furthermore. It will intersect the point B here. But the idea is the same. You push the indifference curve further away until you cannot do it anymore. Until any points on your indifference curve is outside the budget constraint, basically. The idea is that. Okay, and in this case, we have a nice case where, a consumer choose a point H here. Okay, and so in this case, remember the slope is negative W, right? And the slope on this H point for this indifference curve, we call that MRS. Remember? So MRS will the absolute value of the MRS will be W. It will be, just take as a value. Generally speaking, then you're fine. It's negative the slope. A negative wage will be the slope, basically. But that's the general rule, not all the case. Don't memorize this. Okay, I know a lot of you, when you study micro, you memorize that, for example, MRS equals the price ratio. Okay, but you will find that it's not that useful all the time. Okay, for example, the case I just told you, if it is this indifference curve, the maximization point will be here, but the MRS would not be equal to the slope. The other typical situation is this. It is a well-behaved indifference curve, but it somehow still intersect on the kink point. What it means is basically this person will take all his time for leisure. Could be that this person doesn't, their consumption is high enough. He's very rich, so he doesn't want to work. He just wants to put all the time in leisure. Or it could be the case that he really hates work, or he care less about consumption. Either case, theoretically it's possible that we have a corner solution at B. Okay, but notice that this is possible in a micro setting. It is not possible in a macro setting. Why? Because remember, we only have one consumer and one firm. If this consumer doesn't work, then labor supply will be 0. If labor supply is 0, we haven't talked about the firm part, but I think it's not that hard to imagine. If in the firm no one's working, then the production would be 0. If the production is 0, there is nothing to consume. Okay, so there would be a contradiction here. Okay, so this is the general model assumption and what the model looks like. Okay, not very hard, right? Now we will talk about when the real dividend or the tax is changing, what happened for the consumer. We first assume that both consumption and leisure are normal goods. Okay. Remember what's normal goods? When I say normal goods, I'm talking about they are not what kind of goods? What?
They're not inferior goods.
Yeah, they're not inferior goods. Okay? So that means the income effect is 0, positive, negative? Positive. Okay, right. Okay. So an increase in dividend or decrease in tax, that's the same thing. Remember, we have a pi minus t. So an increase in dividend and decrease in tax is the same thing. Exactly same thing. Okay, so in this case, if the dividend goes up, then the consumer will want to consume more C and more leisure. But more leisure means what? More leisure means less labor supply. So it must reduce the quantity of labor supply. Okay? So that's what it looks like. If you increase pi or increase t, it will be a parallel up, right? Like this. It goes, the budget constraint parallelly goes up. And if we assume they're both normal goods, what we will see here is the optimization bundle goes from H to K. So there's more leisure and more consumption. Okay, this is the easy part. Basically, that's income effect. The other one is the increase in market real wage rate. W goes up. As you recall from intermediate and micro, when the price goes up, wage is the price here, right? The price between leisure and consumption, right? So when the wage goes up, that's equal to price goes up. When the price goes up, there's two effects. One is the substitution effect. The other is the income effect. The substitution effect happens because the trade-off between work and leisure, or the leisure and consumption is changed. The income effects changes because when wage goes up, even if I don't do anything, I don't change anything, I don't do any change, then my total wage still goes up. That means I'm wealthier right now. It's just like you have more dividend. It's the same thing. So you will have an income effect. Okay. So when in the substitution effect, when wage goes up, I will for substitution effect, wage goes up means I will sacrifice more leisure, do more work. That means my consumption will goes up. And the income effect tells you that you are richer now, so you will consume more. So either way, you consume more. But in terms of leisure, one tells you that you will consume more leisure. The other tells you that you will consume less leisure. And therefore, the leisure might raise or fall. It looks like this. So, the line, this is the original wage. Wait a minute, let me use blue. This is the original wage, and this is the new wage. W2 goes from this wage to this wage. Then it's a rotate of the budget constraint, right? And when the budget constraint rotate, in this graph, it is showing that this person increased both, sorry, not this one. This one, wait. Yeah. This person increased the consumption and does not change the leisure. It means the substitution effect is, for the leisure part, is equal to the size is equal to the income effect. So you cancel out each other. This is a tips for you. So if you can draw a graph where in the new environment, one of the variable is not changed, that means that is, usually that means it is ambiguous. Because if you tilted the graph a little bit, you will make it increase. And the other way around, you will make it decrease. Okay, so when you can try to draw a graph where it's indifferent, but it is not changed, then you can gain a conclusion that is ambiguous. And as you should probably recall, the line J to K point J to point K here, it is a line parallel to the new wage, W2, but we let it tangent to the original indifference curve. It tangents on the point O. What is this O point? This O point means we are making this person under the new wage. We're making this person poor. We're taking out this person's dividend, for example. Make it as happy as before the wage goes up. Okay, and so here, this person is as poor or as rich as before. So there is no income effect. So from F to O, that's purely substitution effect. And from O to H, that's purely the income effect. And you can see in both cases, C goes up. C has 2 goes up. But for the leisure, it goes down and then goes up. And it happens to be the case that it cancel each other. And given that, for this graph, you will get, what you get is 2 wage. And this wage will give you L1. This wage also give you L1. Right? If you have more points, W3, W4, W5, then you can put it here and put the H minus leisure here. Then what you get is so-called labor supply curve. You know what I'm saying? Here you get a corresponding relationship between W and L, and we can easily put an H minus L, H minus this L before the L, right? So then this will become the labor supply for this wage. So labor supply 1, labor supply, this is also labor supply 1, this is labor supply, maybe some other number, maybe 3, so on. Then one relationship here is 1 point. We can draw many, many points and then get a labor supply curve. Okay, and notice that we have the case where 2 different wage has the same leisure. That means the labor supply is also the same, right? So it means that we have, in this graph, any 2 wage have 2 different labor or labor supply, right? But theoretically, we could have the case where for 2 wage 1 and wage 2, they are the same. And how can you draw that kind of graph? It must be the case that the labor supply curve looks like this. It's backward. Okay. This is the very famous so-called backward bended labor supply curve. Okay. It means that when the wage is high enough, there is a point where you decided that, okay, work 8 hours a day, 5 days a week, with this wage rate is enough for me. I would rather take other time for leisure. I would not take those time to put more time on work, even if the wage goes even further up. And so this is what I was talking about, is when when wage change, what happened to the labor supply? That's change along the line, right? And if it's like what we previously said, is change in dividend or the tax, then it's shift up in the line. Because that's not the endogenous variable that's changing. It's the exogenous variable. Because we have W and labor supply here, N here. So when W changes along the line, when any other thing changes, shift of the line. Okay, we have some special example. For example, this one is perfect complement. Perfect complement, you should have seen this example before, right? This kind of indifference curve before. So if this perfect complement, we know that the consumption bundle must be along a line. And we assume that that line is called C equals AL for some A. Okay, so in this perfect complement case, well, it's actually quite easy to solve for any optimization bundle, right? It's easy. So if we know that any consumption bundle must be along this line. So no matter whether it's change in wage, you know that the optimized bundle is here, or it's change in dividend, so it's parallel. You also know that the bundle is here. So it's easy for you to solve for the bundle. And since it's easy for you to solve the bundle, it's also easy for you to construct the labor supply curve. Okay? But this is also another example where there's no way you can use MRS equals wage to get a solution. Okay, so think about the problem carefully before you apply some kind of formula directly. That's a very important lesson you should learn from economics. This is not a, not a maybe applied math class that you always apply the same method, or this, I should say, this is not a high school math class. You always apply the same formula to solve the kind of same group of questions. For economics, the math is a tool that you need to use for it to help you, not a tool that you blindly use. Okay, so that's for the representative consumer. Next month, actually, because our next class is actually March 1st, I will talk about the representative firm's model. So in that week, I will finish the chapter 4. And for today, that's it for today. Okay, any questions?